This is the solution video for question 17 from paper 1 of the 2019 TMUA or CTMUA exam. In this question, we're asked to find a fraction of the interval 0 to pi such that the following relation holds. Sin 2 theta minus a half times sin theta minus cos theta is greater than or equal to 0, where we consider sine and cos in terms of sine and cos of angles in radians. And we're given 8 possible answers for this question, which are all fractional amounts between 0 and 1. So, to begin with, using this all together feels pretty unapproachable. However, we can attack it piece by piece. So, with a few uses of graphs and working out intersections, etc., we can work out where sin 2 theta minus half is positive, and we can work out where sin theta minus cos theta is positive, and with that information we can work out for what theta this whole expression is positive. So let's deal with this first bit. So sin 2 theta minus a half greater than or equal to 0. So let's draw a sine curve, because it'll just make this a lot easier. So this is a sine curve from 0 to 2 pi, because we're looking at theta between 0 and pi, but because we've got 2 theta here, let's look between 0 and 2 pi. And let's put our line of a half on. So we sort of need to know these intersections. So these intersections, well, we know sine of pi over 6 is a half. So this is pi over 6. And by the symmetry of a graph of the sine curve, we know this should be 5 pi over 6. So we know pi over 6 we've got an intersection, 5 pi over 6 we've got an intersection, and we see between pi over 6 and 5 pi over 6 sine is bigger than a half. So we know for this to be true we need 2 theta to be between pi over 6 and 5 pi over 6, because beyond 5 pi over 6 we can see it never goes above this line again. And simplifying this, so divide everything through by 2, we know this condition holds exactly when theta is between pi over 12 and 5 pi over 12. So now let's look at the other thing in our expression, sin theta minus cos theta. So when is sin theta minus cos theta greater than or equal to 0? Again, let's draw a graph, because we're looking for when sin theta is bigger than cos theta. So if we plot on a graph with sin theta and cos theta, we should be able to see the solution. So here's a graph between 0 and pi. We've got sin theta here and cos theta here. So we've got these two graphs, and we see that after this intersection point, sin theta is bigger than cos theta, and so this will hold. So we just need where this intersection point is. You'll probably know that sin theta equals cos theta when theta equals pi over 4. The other way to deduce this is to remember that tan pi over 4 is 1. So we know that this is pi over 4, and so we know theta between pi over 4 and pi, this holds, and that's exactly what we've got here. So we've got these conditions that we wanted for when these two things are greater than or equal to 0, and from here, if we just carefully tally up when each thing is positive and negative, we can work out when this is positive, and we're done. So when theta is 0, both of these things are negative according to our conditions, and this is true all the way up to pi over 12, which implies this up to pi over 12 is greater than or equal to 0. So this range for theta is good. From here, let's go between pi over 12 to pi over 4. We see this is positive and this is negative, which implies that this is negative, so that range we don't have our condition. Now from pi over 4 to 5 pi over 12, we have thetas in this interval and in this interval, which means both of these are positive, which means our product is positive. So that's another good range. And then finally, theta is bigger than 5 pi over 12, but less than pi. We have thetas outside this range, so this is negative, but this is positive. And so we get negative, and therefore this is all the theta for which our condition holds. So we just need to work out what fraction of our interval of 0 to pi this is. And you'll see that this is a 12th of the interval, and this is 5 over 12 minus a quarter, so 2/12 of the interval. If we had a 12 to 2/12, we get a quarter, And so this is a fraction of the interval for which our condition holds, which matches answer C in the multiple choice, and so our answer is C.